In this video, I'm going to discuss the derivatives of inverse trigonometric functions within the calculus topic. Okay, so as you can see here, so this are the formulas of the inverse trigonometric functions. Okay, starting with the sine inverse u. Okay, if you take a look at some of your lecture notes or the textbook, you'll notice that the formula will start in such a way that will be sine inverse x, cosine inverse x, tangent inverse x, cotangent inverse x, secant inverse x, and cosecant inverse x, and then they won't have the expression of u over here. Instead, they will have, for example, for sine inverse x, you will have 1 over square root of 1 minus x square. Okay, the reason why I'm coming up with this type of expression is because later on you will be using the substitution method, where you will be using the variable u, and then you let by the certain variable of x. Okay, so that's why I straight away put in this form itself. Okay, so let me give you a quick recap regarding the inverse trigonometric functions and the derivatives. Okay, so let us begin with the sine inverse u. Okay, for sine inverse u, okay, the derivative will be u prime divided with square root 1 minus u square. Okay, whereas for the cosine inverse u, okay, the difference is just a negative in front, otherwise it's just the same. Okay, that is why, as you can see here, I box in the yellow color. Okay, those who are having a yellow color, okay, indicates that they're having a negative properties over here. Okay, so sine inverse u and cosine inverse u, okay, they're almost the same. The only difference is for the cosine inverse u, you have a negative in front. Okay, so from here we can know that, so cosine inverse u is equals to negative u prime divided with 1 minus u square. Okay, so this is for the cosine inverse u. Okay, and then proceed for the next formula, tangent inverse u. Okay, from here you have u prime divided with 1 plus with u square. Okay, this is for the tangent inverse u. Okay, whereas if you take a look at the cotangent inverse u, okay, the difference is just a negative u prime divided with 1 plus u square. As you can see here, the relation between tangent inverse u and cotangent inverse u, they are almost similar. The only difference is they are having the negative symbol for cotangent, guys. Okay, so these are the relationship between the tangent inverse u and cotangent inverse u. Okay, so let us move on to the last two formulas, which is the secant inverse u and cosecant inverse u. Okay, similar concept. For secant inverse u, the derivative will be u prime divided with modulus u times with square root u square minus 1. Okay, for cosecant inverse u, the formula almost the same. The only difference is it has the negative in front. Okay, so this is basically the relationship between secant inverse u and cosecant inverse u. Okay, so in shortly, I would like to conclude that, okay, the relationship between sine and cosine, okay, you have a negative, and then tangent and cotangent you have a negative, and then secant and cosecant you have a negative. Okay, shortly I would say that anything you have a co in front, that will have a negative symbol. Cosine, cotangent, cosecant, everything you start with the co in front, you have a negative symbol over here. Okay, so technically you only need to understand the main of this sine inverse, tangent inverse, and secant inverse. Okay, so enough with our explanation, so let's jump into our exercise now. Okay, I will be showing you some of the examples where I'm sure by end of this video you will able to understand the derivatives of inverse trigonometric functions better. So let's dive into the examples now. Let us begin one of our examples, starting with the sine inverse. Okay, but before that, let me write down the formula for the derivation of the sine inverse. Okay, so given that d over dx, okay, in a bracket, sine inverse u. Okay, so from here you'll be getting u prime, okay, divide with square root 1 minus u square. Okay, let me underline the fraction and the square root. Okay, right, and let me box the formula. Right, okay, so let us start our example. So this is what we are waiting for. Okay, example. So from here, given that you have a expression of let's say for example sine inverse 3x, sine inverse 3x. Okay, so from here how are we going to solve this? Okay, so from here, okay, let me show you the step by step. So what you're going to do is we're going to use the substitution method, okay, by letting u is equals to x 3x, okay, by letting u is equals to 3x. Okay, so from here we're going to differentiate u prime with respect to x. So from here, to get the u prime, what you're going to do is we're going to differentiate 3x. So by differentiating 3x, you're only left with 3. Okay, so from here, once you've done this, you just substitute these following values into the formula over here, the sine inverse u. Okay, so from here it will be equals to 3 divide with 1 minus, instead of writing a u, you need to write 3x over here. Okay, instead of writing u prime, you need to write that 3 over here. Okay, 1 minus, in the bracket, 3x close bracket square root. Okay, let me underline this. Okay, we still have one more step left. Let us complete our expansion. Okay, 3 divided with square root of 1 minus 3x square. Okay, so from here your final answer will be 3 divided with square root of 1 minus 9x square. 3 divided with square root 1 minus 9x square, guys. Okay, so let me underline this. Okay, and then underline the fraction line as well. Alright, okay, and let me show another example. Okay, if this example, if my thing is easy, okay, let me show you another example which is slightly complicated. Okay, let's say you have a derivation of d over dx. Okay, let's say you have sine inverse 4x squared. So from here, how are you going to solve? Okay, so let me show you the step by step. Okay, the step is still the same. Okay, so from here we're going to let, okay, u, variable u is equals to 4x squared. Okay, so from here we're going to differentiate this. So from here you'll be getting u prime is equals to, so we're going to differentiate this with respect to x. So 2 times it 4, you get 8, and the power you minus by 1. So from here you get is 8x. So from here u prime is equals to 8x, u equals to 4x squared. So from here, for the next step, what you're going to do is we're going to substitute this following variable into our equation over here. So from here will be equals to, instead of writing u prime, we're going to write as 8x. Okay, instead of writing u, we're going to replace it with 4x squared. Okay, so 8x divided with square root 1 minus, in the bracket, 4x close bracket squared. Okay, so let me underline the square root. Okay, and underline the fraction. Okay, so from here 8x, okay, and then divide with, so from here we expand the 4x square. So from here you get is 16x to the power of 4. So from here you'll get 8x divided with square root 1 minus 16x to the power of 4. Okay, let me underline this as well. Oops. Okay, please hold on. Okay, so let me underline the solution. Okay, and for the first one as well. Okay, so I hope you understand the concept from the derivation of sine inverse. Okay, let us proceed to the cos inverse now. Okay, let us proceed to our cosine inverse derivation. But before that, let us write down the formula for cosine inverse derivation. So from here, d over dx, okay, in a bracket given by cos inverse u, okay, it will be equals to negative u prime divided with 1 minus u square square root. Okay, that is the most important thing, guys. Okay, because the formula is almost similar as the sine inverse, the only difference is you just have to times with negative. Okay. Okay, let me box this formula. Okay, and of course we're going to discuss one example. Okay, let me discuss one example over here. Okay, so given that you have cos sine inverse 2x, okay, cos inverse 2x. So from here, how are we going to solve this? Okay, so let us do the working now. Okay, so from here we're going to let u is equals to 2x. Okay, we are using the substitution method. Okay, this 2x we're going to let as a variable u. Okay, and then we're going to differentiate u. From here we get u prime. Okay, and then we're going to differentiate 2x. So from here we're going to get 2. Okay, u is equals to 2x, u prime is equals to 2. Okay, and then from here, so we're going to proceed with the working. Okay, so we over here we have negative u prime over square root 1 minus u square. So we can just straight away substitute the respective values into the formula over here. So from here it is equals to, so u prime it is 2, okay, and then divide with square root 1 minus, okay, in a bracket 2x squared. Okay, so let me underline the square root line and then the fraction, of course, that is very important. Okay, so for our final step, it will be equals to, most important, negative, guys. Okay, so from here negative 2 divide with square root 1 minus 4x squared. Okay, so this is your answer. Okay, so let me underline the solution. Okay, so this is a short and simple explanation behind the inverse trigonometric functions for cosine inverse, guys. Okay, so from here let us proceed to the tangent inverse. Okay, so from here let us discuss for the tangent inverse trigonometric functions. Okay, but before that, let us write down the formula. Okay, given that d over dx, okay, in a bracket tangent inverse u, okay, it will be equals to, so from here it will be u prime divided with 1 plus with u squared. Okay, so this is the formula, and let us box this formula as well. Okay, so let us discuss one example based on this tangent inverse trigonometric function. Okay, so from here, given that you have a problem of tangent inverse x over 6. Okay, so from here, how are we going to solve this? Okay, the step is very standard. Okay, so from here what you're going to do is we're going to use the substitution method. So from here we're going to let u is equals to x over 6. Okay, so from here we're going to differentiate the equation. So from here, u, when you differentiate, you get u prime, okay, and then equals to x over 6 when you differentiate. Okay, x over 6 is actually 1 over 6x. So when you differentiate, you only left with 1 over 6. So from here, u prime is equals to 1 over 6. Okay, so from here, we already have the u and u prime, which is x over 6 and 1 over 6 respectively. So what we can do is we can use this value and substitute into the following equation. Okay, so from here, let us solve this following example. So from here it will be equals to 1 over 6, okay, and then divide with 1 plus with x over 6 squared. Okay. Okay, and then equals to, so from here you still have 1 over 6 in your numerator, okay, whereas in your denominator it will be 1 plus with x squared over 36. Okay, so from here what you're going to do is, we try to standardize the equation. What you're going to do is, we're going to eliminate the denominator. So how we're going to do that? We're going to times the whole equation by 36. Okay, 36 at the denominator and 36 at the numerator. Okay, so from here at your numerator you will have 6. So 1 over 6 times with 36, you will have 6. Okay, so from here when you times the whole equation, I mean the whole denominator, by 36, so you will have 36 plus with x squared. Okay, so this will be your answer. Okay, so from here, so this is your answer for the example where involving the tangent inverse. Okay, where you have 6 over 36 plus with x squared. Okay, we still have 3 more remaining inverse trigonometric functions, which is cotangent and then secant and cosecant. Okay, let us take a look at one by one, starting with cotangent. Okay, let us discuss the cotangent inverse function. Okay, the cotangent inverse function is very much similar to the tangent inverse function. It's just the negative version of tangent inverse function, guys. So technically, if you able to understand the tangent inverse function, the cotangent is just the negative version. Okay, so let me write down the formula of the derivatives of inverse trigonometric functions for cotangent. So given that d over dx, okay, in the bracket, cotangent inverse u is equals to negative u prime, okay, divide with 1 plus with u squared. Okay, so let me box this formula. So from here, let me discuss one example. Okay, so let's say you have a cotangent inverse 6x cubed. Okay, cotangent inverse 6x cubed. So from here, how are we going to solve this? Okay, so let us take a look one by one. Okay, so from here, we're going to use the substitution method. So from here, we're going to let u is equal to 6x cubed. Okay, and then we're going to differentiate the equation. So from here, in the left hand side, so from here you get is u prime. Okay, for your right hand side, so from here you get is 3 times 6, here you get 18x squared. Okay, the power 3 you minus with 1, so you're only left with 18x squared. Okay, so from here you have u is equal to 6x cubed and u prime is equal to 18x squared. So we can use this information and solve the following question by applying the following formula over here. So let us solve them. So from here, negative u prime, okay, so it will be negative 18x squared. Okay, and then divide with 1 plus with u squared. Okay, since our u we get here is 16x cubed, it will be 1 plus with 6x cubed to the power of 2. Okay, so from here you'll get negative 18x squared. Okay, and then divide with 1 plus with 36 x to the power of 6. Okay, so the power will be raised to the 6, so it will be 6 square and then times with x to the power of 6. So 6 square will be 36 and then times with x to the power of 6. So that's how you get the whole expression over here, 1 plus 36 x to the power of 6 over here. Okay, so from here let us underline the solution. Okay, now we have come to the last two inverse trigonometric functions, which is secant inverse and cosecant inverse. Okay, let me write down the two formulas respectively. So given that d over dx secant inverse u, okay, is equals to u prime, okay, and then divide with modulus u times with square root u square minus 1, u square minus 1, okay. So let me box this. Okay, so this is for secant inverse, okay, whereas for cosecant, the difference between the secant and cosecant is just a negative symbol. Let me write down as well. Okay, for cosecant inverse will be equals to negative u prime, okay, divide with modulus u times with u square minus 1, okay. So let me underline the square root and box the formula as well. Okay, so from here, let us solve one example. So from here, given that d over dx secant inverse 2 plus with x squared, okay, close bracket. So from here, how are we going to solve this equation? Okay, so from here, let us do the working one by one. Okay, so from here, what we're going to do is we're going to solve using the substitution method. So from here, we're going to let u is equals to 2 plus with x squared, okay. So from here, we differentiate both sides. On your left hand side, you get u prime is equals to, okay, on your right hand side, you're only left with 2x, okay. So from here, okay, we got u and u prime. Now we can use to solve the following equation by using the secant inverse formula. So from here, let us start to solve this. Okay, so from here, u prime is 2x, okay. So from here, 2x divide with, okay, modulus u, okay, in this case modulus u is will be 2 plus with x square, close modulus, okay, and then square root times with square root 2 plus with x squared in a bracket square minus 1, okay. So from here, let us expand this inside bracket. So from here, 2x, okay, divide with, okay, times with the modulus 2 plus with x square, close modulus, okay, and then times with the square root. So from here, it will be 4 plus with 8x squared plus with x to the power of 4, okay, and then minus with 1, okay. So from here, it will be equals to 2x, okay, and then divide with 2 plus with x squared modulus, close modulus, okay, and then times with, so 4 minus 1, you're only left with 3, okay, 3 plus with 8x squared plus with x to the power of 4, okay. So let me underline square root and the fraction as well. So clearly you can leave your answer in this way, guys, okay. So from here, let me underline the solution. Okay, the reason why I don't discuss for cosecant, because the properties are very much similar. but if you want me to discuss also can. Okay, so if you want, I will show you another one more example for especially for cosecant. Okay, so let me proceed to example 2. Okay, example, okay, where you have d in a bracket dx, okay, where you have a cosecant inverse 5x. Okay, close bracket. So from here, how you're going to differentiate it? Okay, simple concept. Okay, so I proceed my working over the right hand side. Okay, so from here we're going to let u is equals to 5x. Okay, so from here you get your u prime is equals to 5. Okay, so from here we got u and u prime. So what you're going to do is we're going to substitute this following expression into this equation over here, cosecant inverse. Okay, so from here equals to negative u prime. In this case our u prime is 5, so it will be negative 5, okay, divide with modulus u. Okay, in this case our u is 5x, modulus u will be modulus 5x, okay, times with u square minus 1 square root u square minus 1. So from here u is 5x, so from here 5x square minus 1. Okay, so square root 5x minus 1. Okay, let us solve them. Okay, so from here you get negative 5 divide with modulus 5x, close modulus, okay, and then square root 25x square minus 1. Okay, okay, so you can literally leave your answer in this way. So let me underline the solution. Okay, so that is all for our discussion regarding the inverse trigonometric function. Okay, so I hope you understand the full concept that I've explained to you. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming advanced mathematics video content in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.